Good morning. How are you? How is your weekend? I take this chance to welcome you to our today's lesson, which is part 2 of the mole. And we are only going to check on two concepts, that is empirical and molecular formula. So stay with me from the beginning to the end and confirm to me where you're watching me from, so that I can know who is in class, who is not in class. So the two concepts, empirical and molecular formula, they are dependent of each other. Meaning, for us to get molecular formula, we need to have empirical formula. So now, when it comes to empirical formula, we are going to see two examples, then we see two examples of molecular formula, and you will be ready to go. I told you yesterday when we were discussing on the Form 2 topic, which was about the chemical equations. I told you that I will only show you how it should be done. I do with you 2-3 examples. Then from there, apply what you have learned to perform many other operations. So today, we are only learning, I will explain to you. I give you two concepts, two examples in each case. Then from there, you will be free and ready to go and proceed. So those who are in, you can tell me about my audibility. You can tell me about how you can hear me, where you're watching me from. So what is there is, let me start the topic. So we have what we call empirical and molecular formula. Yes. So now, when you combine very many empirical formulas, it gives you molecular formula. For example, look here. If you have a compound called methane, which is written as CH4. This is, CH4 is simply an empirical formula. But now, if we combine very many CHOs, like 2 of them or 3 of them, then it's going to give us a molecular formula. For example, if we combine 2 CH4, we are going to have, you simply multiply by 2, we are going to have C2H8. So this is now the molecular formula. Why? It is made up of 2 molecules. It's made up of 2 molecules of methane. If this one has a molecular mass, or simply the formula mass of 4 plus 12, if this one has 16, this one will have 32. It can be made of 2 molecules of 3 or 4 or several to give you molecular formula. That is what you need to know. Now, let's just see how we can work on empirical formula. I will give you one example and another example. Let me show you how. We all know the formula of magnesium oxide. We all know the formula of magnesium oxide. It's a magnesium and oxygen. So for you to come up with the formula of magnesium oxide, MgO, we must put into consideration the I want you to draw something like this. We are now seeing how we can come up with the empirical formula. So first of all, we must identify the elements reacting. Elements reacting. I will just write elements, but of course it is the elements reacting. Then we have magnesium here. Then we have oxygen here. In that way, that is the first step. The second step, masses reacting. We have known that now it is magnesium and oxygen. But the question is, what are the reacting masses? What is the available magnesium and available oxygen that are supposed to react? In our example, I would use 0.84. Then I'm just using an example that I created. Then this one I used 0.56 grams. Before we continue, let me say this, and I hope you will also get me very well, so that next time, in case I don't get an example that behaves that way, you will already know. Now, Sometimes you are not given the masses reacting, but you are given the percentage by mass. Percentage by mass. So you are supposed to be knowing. If you are told this one is 80%, this is 20%, that 80 is what is supposed to act as the mass. You will use them here. Are you together up to that point? Now, after you've written the reacting masses, now we need to check on what we call the molar mass. Ama, there are those who will call it the molar mass. There are those who will call it relative atomic mass. I mean, whatever the case. Na kila mtu anajua. For magnesium inakuanga 24. For oxygen inakuanga 16. Then ukishafika hapo, you see now we have step 1, step 2, step 3, then we have step 4. And always, when you have the masses reacting, you have the masses and then you have the molar mass. What comes in is the mole. The mole. The mole, ama moles. So, ukiwa na hivi, uko na mass na uko na molar mass, you simply divide 0.84 divided by 24, you will get the number of the moles. In my case, I got 0.35. The other case, I got 0.35. So, to go number 4, you are supposed to get 5. Number 5, the mole ratio. Mole ratio is done directly. Mole ratio is, you take moles of the one, then you divide across. Always pick the one with the least moles. Unaangalia 0.35 na 0.35 kani ndio ndogo. You pick the smallest, but in our case, they are the same. So I can just divide with any 0.35, 0.35. You get 1, 1. Mole ratio means, now we have 1 magnesium, 1 oxygen. So the mass, the empirical formula is going to be Mg1O1. Which is correct, but I told you yesterday, when writing ikiwa 1, you don't have to indicate. So this is the case. That is the first example. At that point, you have some concepts on how it should be done or how it should go. Are you together? Yes. So let's look at the second example. On how we do empirical formula. I want us to consider, I use the case of copper and oxygen. So I'm going to wrap this one because these ones will remain the same. Here copper and oxygen. Hata hii mshaelewa maana yake, so let's not use it over there. RAM ya copper inakuanga 63.5. I will work with 63.5. Then the mass for oxygen I used, the MM for oxygen is 16. Inabaki hivyo. So ukishapata mass, then the molar mass ama the RM calculator, say 2.8 divided by 63.5 for 4. That is what my calculator gave me. The same to this divided by this, you will get 0.044. What will happen here is this. Just now, you divide by one of them, especially the one that has the least number of moles. So you have it this way, 1, you have it 1. So it is going to be CuO. Utaacha utoto ya kuandika 1, 1. And that is how it should be. That is the second example. I think now we can get to the third example. Linda, you're asking which form is this? This is form 3 moles. Ukisoma hapa the mole, kwani unajua mole iko form? It is in form 3. Yes. Now let's look at another example. Let me use silicon and oxygen. So I'm just changing the formulas here. I'm just changing the elements reacting. Do you know the formula? My body is moving. Do you know the formula for silicon? Use Si. For oxygen is O. So that is the first step. Nimewambia, there are just 5. So what is there is, from there, I used percentage. Percentage hii iko na 47. Hii ingine, of course, automatically, hii ikiwa na 47, hii ingine iko na 53. That one should be just a self-explanatory thing, because hii ni 47, hii ingine itakuwa 53. For silicon, what is the atomic mass for silicon? Use 28. For oxygen, use 16. Then from there, get the moles. 47 divided by 28. I got 1.68. Also, tell me what you are getting in your calculator. Then this other one, 53 divided by 16, I'm getting 3.31. These are now the moles. What you're supposed to do is to get the mole ratio. How? Take the smallest. Hata sikuwa zimepangana tatu. Pick the smallest, divide by the moles across. So it's going to be divided by 1.68. Divide by 1.68. You will get one here. Then this one gave me 1.94. Roughly, this is 2. So you round off to 2. There are 2 ways of rounding it off. Either back or forward. This one you round it off barely, because 1.94 is very close to 2. So we have SiO2. That is the empirical formula to silicon for oxide, or when silicon and oxygen react. Yes. So let's go to last example, because in our last example there is something I want to show you. In this, look at this. Hii tumepata ikiwa 1.94. What if tungepata ikiwa 1.5? Tungefanya nini? My last example takes place or takes care of that. Look at this. I want to deal with iron and oxygen. Iron inaandikwa hivi. Then oxygen. Percentage by mass equals 70%, equals 30. The RAM for iron work with 56. For oxygen, we have agreed up with 16. So the moles we will get, if you take 70 divided by 56, in my workings, I got 1.25. 30 divided by 16, you will get 1.875. Now get the mole ratio. Of course, you pick the smallest, you divide with the others across. Divide by 1.25. You divide by 1.25. This one gives you 1. Sawa? The other one gives you 1.5. So here, you cannot round off. Because after kama will you round off this to 3, to 2 or to 1? If it is 1.5, 2.5, you simply multiply by 2. Divide times 2 times 2. If by multiplying by 2 removes the decimal, then go with it. So we will have 2 and 3. So we will have iron 2O3. That is iron 3 oxide. So inafaa unaangalia hapa, if by multiplying by 2 will remove the decimal place, then it means you can do that. You can just multiply. But kama ni round off, ukipata 1.8, 1.9, you round off to 2. Ukipata kitu kama 1.1, 1.2, sijui 1.05, you round it off back. I don't know whether we are together. Yes. Let's look at molecular formula. I've done 3 examples of empirical formulas, and remember what I said. Okay, for molecular, I will only do maybe 2 of them, and you will be okay with it. So let's look at the molecular formula. Let me pick a question here niweke kwa chat section, then mufanye those who are in class. Watu leo weekend wameenda wapi? Who is in class? If you're in class, type yes. Nikuone. So we have this question. Nimeweka hapo kwa chat section. A hydrocarbon was found to contain 92.3% carbon, and the remaining is hydrogen. So the remaining is the other percentage, 92.3. Then 100 minus hiyo. Kuna mtu aliandika 8.7. No. because I'm on 92. So yeah, from where 192 in a parking 8. No, 100 minus 92.7 is 7.7. So I remember when we say hydrocarbon, let me clean the board. I explained to you something. Hydrocarbon. When you ever heard of a compound known as hydrocarbon, that compound, don't ask, it's made up of what? It's made up of hydrogen and carbon. Hydrocarbon. Now, this compound, the elements include venye tu nimesema hydrogen and carbon. Percentage by mass or simply the mass, nimesema ingine iko na ngapi? Ingine iko na 92, carbon ndio 92.3. Of course ingine itakuwa 7.7. Yes. Now we get the RAM. For hydrogen is always 1, ingine ni 12. So let me see how I worked it out, because size in a calculator. So I have to follow it up how I did it. So we are going to have, if you divide 92.3 by 12, you will get 7.7. If I'm not wrong, then ingine 7.7 divided by 1, it gives you 7.7. So these are the moles. Then mole ratio, it will be 7.7 divided by 7.7. 7.7 divided by 7.7. So we get 1:1. So this is the empirical formula. Answer na CH. This is the empirical formula. But the question imesema aje? The question imeproceed ikasema if its molecular mass is 78, meaning tuki-add E molecular, yani tuki-combine, if you add molar mass ya carbon which is 12 plus 1 ya hydrogen which is 13, tuta-combine 13 is ngapi ndio ifike 78. In short, I'm saying this, we have and we always work with n to give us 78. So in the bracket n is equals to 78. Then we have 13n is equals to 78. So nataka useme n ni ngapi? I think it's 6. Ukishapata n to be 6, peleka hiyo n pale. Open the bracket now. So you have C6H6. This is now the molecular formula. I think that's okay. Unless kama uko na swali. Whoever is in class, if you have any question, tell us. Yes, so that's how you can get the molecular formula. I want us to do the last question for the day. And that is all about empirical formula still. I'm copying the question. Then I paste it on the chat section there, so that those who are there can get the question. For the sake of those who will watch later, let me read the question so that they can write. A compound of carbon, hydrogen, and oxygen contains 54.55% carbon, 9.0 hydrogen, and 6.6% oxygen. If its relative molecular mass is 88, what is its molecular formula? Yes. How many compounds? How many elements here? Carbon, hydrogen, and oxygen. So we have elements. Tuandike hivi. Just write elements, and you go back to the questions: carbon, hydrogen, and oxygen. Percentage by mass ama mass. Waje tuone. Ingine imesema 92. Sorry. Ingine imesema a compound of, okay, so iko na 54.55% carbon. 54.55. Carbon 9.0 hydrogen, 9 for hydrogen, What about oxygen? Oxygen, it's giving us to be 36.6. Yeah, that's 6.6. Now, from there, the other information that you are given is that if its molecular mass is 88, if its molecular mass is 88, calculate the molecular formula. So first of all, let's proceed using the steps that we require to get the empirical formula. Then from empirical formula, we will get the molecular formula. So from here, we get the RAM. Na nimewambia, you can either be given or you are not given. So hapa ni 12, hapa ni 1, hapa ni 16. Then from there, you get the mole ratio. Wherever you have mass and RAM, the next thing is mole ratio. You and I class my equation is straightforward. It should be mole ratio. So, okay, first of all, moles, then we get the mole ratio. 54.55 divided by 12. I want you to take your calculator. You will get, from my side, I got 4.55. Then this other one, this one should be 9.09. Yes, now equate 100. If you divide by 1, what will you get? 9.09. That's 6.6 divided by 16. You will get 2.27. 2.227. So you get now the mole ratio. Ukishapata moles, you get the mole ratio. Now look at this. We have these moles. We have 9.09, then we have 2.227. So what you are supposed to do, take the smallest, divide across. Divide by 2.27, divide by 2.27, divide by 2.27. Of course, you will get 1. 9.09 divided by 2.27. What will you get? My calculator gave me 4. I don't know what yours is giving you. 4.55 divided by 2.27, you will get 2. Meaning, this for formula is C2H9, then O1. But you can just write that as stars. So the whole of this, if we get its molecular mass, it will give us to be 88. Your manner, we are supposed to do it this way. For carbon, we know one carbon is 12. So we are going to have 24 plus 9. You know, one hydrogen is 1. Then there are 9 plus 16 for oxygen into bracket N should be equal to 88. So you can add for me these ones. 24 plus 16. What is it supposed to give you? No, you are here, it's supposed to be 4. Carry this 4. This I think I'm the one who has carried it wrongly. So hapa inafaa ikuwe 4. So that we have 44 N. So our N is going to be 2. Ukishapata N ikiwa 2, peleka hiyo 2 pale, you open the bracket. Then you will have C4H8, then O2. That is now the empirical formula. So I believe now, after going through that, how many examples have we gone through? I think we've gone through like 6 examples. So when you go through them, you will be in a position now to work on others. I will be sending the questions to the group. Those we are in the same group, make sure you remind me so that nitume maswali za empirical formulas. You work on them so well that you become perfect on the same. The other thing is our lessons on afternoon will continue as from Monday. Starting time is 3 p.m. All the way up to 4 or whatever time it will reach. And this week we've done so well. Next week, the same thing, we shall be doing it. Then keep on requesting for the exams we have just given over there. And we will supply to wherever you are. Otherwise, having no much to say, the other Saturday, we will be doing part 3 of the mole. Or, if not Saturday, I will fix it on a Friday evening because weekends we shall be doing something different from teaching, which you are also invited. We shall be having some talks on the same, which you are also. So, those who are watching later, watch, then the questions are just on the chat section. You will get them from there. We are stopping there. Thank you for being my online student. Thank you. Imekata.